Hello everyone, welcome back. In this video we're going to take a look how to delete a node from a doubly linked list by value. Say I have this doubly linked list with number 10, 20, 30, 40, 50. The user should be able to delete any node by its value. Say the user want to delete number 40 or number 30 or 10 or whatever. So there are still two corner cases. If the value is at the beginning of the linked list, so we need to update our head pointer. We saw many times how to delete from the beginning of a doubly linked list. And if the value is at the end of the linked list, we need to update our tail pointer. We saw that also. So let's define a function and first take care of deleting from the beginning of the linked list. So I'll define a function here, public, let's call it void delete by value. So this function accepts a value from the user. Let's call it value. First we check if the list is empty, we return. If is empty, we prompt the user and return. Otherwise we'll check if the data is at the head of the linked list. We'll say if this dot head dot data is equal to value. Again, there will be two cases. If the list has only one node or it has only one value, so we are going to detach the head pointer and tail pointer from that value. Since in a doubly linked list, if we have only one node, both the head pointer and the tail pointer will point to the same node. If this dot head equal to this dot tail, if both these pointer point to the same node, we set them both to null. This dot head equal to this dot tail equal to null. Otherwise, if there are more than one values in our doubly linked list, we just want to update our head pointer. In the else block, I will say this dot head equal to the next node, to this dot head dot next. Then we will set the new head's previous pointer to null. We'll say this dot head dot previous equal to null. So this way we can delete from the beginning of a doubly linked list. In the else part, if the value to be deleted is not at the beginning of the linked list or head node, what we are going to do, we start traversing over the linked list and check the next node's data until we find the value to delete. Say the user want to delete number 30 from our linked list. The user enters value as 30. We will, as usual, maintain a temp pointer initially pointing to head to traverse over the linked list. So I will check while temp.next is not equal to null or until we have next nodes, we keep traversing, and each time we check if the data of the next node is equal to value. If we found it, so we can delete that node. So let me define a temp pointer node, temp equal to head initially, while temp.next not equal to null. Until we have next nodes, we keep checking. We will check if temp.next, which is this node, dot data, which is this data, equal to value. We will check that if temp.next node of next node, we want to check the data, the dot data equal to value. If the condition is true, we found the node to be deleted. So we are going to delete it inside the if statement. In the else block, we are going to just increment our temp pointer, temp equal to temp.next. So while temp.next not equal to null, no temp.next not equal to null, temp.next stores memory address 200. We go inside the while loop. We will again check if temp.next.data equal to value, temp.next, which is this node or memory address 200. This node's.data, which is number 20, equal to 30. No condition is false. We go to the else block. In the else block, we say temp equal to temp.next. So temp comes to the next node in our doubly linked list. Temp points here to memory address 200. Again, we will check temp.next not equal to null. No, temp.next is points to memory address 300. It is not null. We go inside the while loop. We will check again if temp.next.data equal to value, temp.next, which is this node.data, which is number 30, equal to value. Yes, condition is true, and we going to maintain a pointer to this node, to the node we want to delete. So let's call it a node to delete, or let's call it nd, or node to delete. So Inside the if statement, I will define a pointer, a node to delete equal to temp.next. Temp.next is the node that contains the data, so we are going to delete this node. Once we got a pointer to the node we want to delete, we are going to detach these links and establish a new link between the previous node of the node to be deleted and the next node of the node to be deleted. So first let's maintain this link. We will say temp.next, which is this pointer. We will have it point to memory address 400 instead of pointing to memory address 300. So let's do that. Here I will say temp.next equal to memory address 400. I can access memory address 400 using this pointer node to delete dot next, which is this pointer. It stores memory address 400. So I will say temp.next is equal to node to delete dot next. So we will maintain this point connection, and instead of memory address 300, this time it's going to store memory address 400, and this connection or this link will be detached. Then we will establish this link between the previous node of node to be deleted and the next node of the node to be deleted. We will have this previous pointer point to memory address 200 instead of pointing to memory address 300. So where can we access this pointer? We can say node to be delete dot next, which is this node dot previous, which is this pointer. So let's do that. Node to delete dot next node. Of that next node, we want to update the previous pointer. Previous pointer equal to, we want to update it to temp. We want it to point to this node instead of this node. So let's do that. We can access memory address 200 by temp, since temp already stores memory address 200, or we can say node to delete the previous pointer. So let's use temp pointer. I will set it to temp. Once we set this link, link will be detached. If you want to break these links too, so we can say finally here we say node to delete dot next pointer equal to node to delete dot previous pointer equal to null. We want to disconnect these two pointers if you want to do that, otherwise the garbage collection will delete that node. Once we say node to delete equal to null, so once we say node to delete equal to null, this link will be detached, and this node is not referenced by any pointer. It's going to be eligible for garbage collection. So let's write code for that. I'm going to jump to IDE. In the else block, we will check while let's maintain a temp node temp equal to this dot head. We'll check while we have next nodes or temp dot next not equal to null. We keep traversing, and each time we check if temp dot next dot data equal to value. So once if we found the node to be deleted, we will maintain a pointer to that node. We'll say node, let's call it node to delete equal to temp dot next. Then we'll say temp dot next. We'll have it point to the next node of node to be deleted. We'll say node to delete dot next pointer. Then we will have the next node of node to delete to point to its previous node, which is going to be temp node or temp pointer. So we'll say node to delete dot next node. Of that node, we want to update the previous pointer equal to temp. So that's it, I think. Finally, let's decrement the size. This dot size minus minus. We're gonna get an exception if we wanna delete the end of the linked list. or the value resides at the end of the linked list. We will take care of that, but right now let's check this code. Okay. In the else block here, we are going to say temp equal to temp.next, otherwise we will get infinite loop. Let me run the code. So we have these 10, 20, 30, 40. Say I wanna say list.delete by value. So I wanna delete number 10. So 10 is gone. Say I wanna delete number 20. 20 is gone. Let's delete 40 also. 40 is gone. But if I want to delete number 50 or from the end of the linked list, so we will get a null pointer exception. It is because say the user want to insert delete number 50, so value equal to 50. So we will definitely have a temp pointer here, temp. We will check while temp.next not equal to null, no temp.next is not null. So we go inside the while loop and we will check if temp.next data, which is number 50, equal to value. Yes, condition is true. When we say we will have a pointer here, node to delete, then we will say temp.next equal to node to delete.next. So temp.next, which is this pointer, is going to point to null, and node to delete.next is null, so we'll have null here, and this link will be detached. Again, when we say node to delete.next.previous, so node to delete.next, which is null.previous, we get a null pointer exception because this pointer is null. That's why we need to have an if statement. If the value to be deleted is the tail or the end of the linked list, so we just want to update the tail pointer. We will bring tail pointer here and we will set this next pointer to null. So it's already to null. So I just want to update the tail pointer. Before updating this link, I'm going to check if the node to delete is the last node. If node to delete equal to tail, this dot tail. Or we can say if node to delete.next equal to null. We are going to update our tail pointer. We'll say this dot tail equal to this dot tail dot previous pointer, or we can use the temp pointer since temp and tail dot prev both points to memory address 400. So we can use either of them. In the else block, we are going to update this link, node to delete.next.previous equal to temp. I'm gonna put it here. So let's run our code. It should be working. So number 50 is gone. Thank you guys for watching. Please don't forget to subscribe and see you in the next video. Bye bye.